Okay, I pray that my mic is working because it didn't work on my last video. All right, guys, so today I'm not going to be here. I'm going to try to do as much of this back and forth. So I'm going to be toggling back and forth. So just stick with me. Sorry about that. So make sure you guys get the do now done. That's what you need to work on for 10 minutes. I'll put a 10-minute timer on there. So make sure you get it done. Then after that, once you submit it, I'll have the answers returned back to you guys if I'm not there. All right, so after that, you guys, we're going to be doing our Monday notes. I will show you guys, I'll just go through the answers with you guys and show you why. Um, this one, we need to put this in y equals, so that's going to be doing the line, subtracting 4x from both sides. We would cancel out the 4x. We'd be left with negative 7y equals negative 4x minus 2. Then we're going to divide negative 7 by each term. And then we're going to be left with y equals 4 7x plus 2 over 7. So that's how we put that in y equals mx plus b. This one's going to be not a function because we see that the x values would repeat. We have a repeating 0 and repeating 1, so it would not be a function. This one, the linear correlation coefficient of a set of data is negative 0.213, which is the best description of the relationship between the data set. This is a weak correlation because it is not close to 1, and it's going to be negative because there's a negative front of it. And if you want to look for those correlations, you would make sure you put your stat diagnostic on, and then you'd be looking for the R, and that will tell if it's positive or negative. This is a simultaneous equation. And basically, we want to look at the point of intersection to see where those are. And that would be 18 and 15. Okay, so in 18 days, they've got 15 ribbons left. So that's what that one's going to be. Frank and Erica are selling ribbons to raise money for a football team. The graph shows linear relationship between the number of ribbons. Uh, each of them has left to sell the number of days that they have been selling ribbons. On which day does it appear that Frank and Erica will have the same number of ribbons left to sell? So it'd be 18 days, 15 ribbons left. So what is the rate of change of the number in which the plant grows, which represents the number of days it grows? So this is when you find two pretty points. Let me just click through it. You find two pretty points, you put it in stat edit. I would do 0, 0 because it's the origin, and then 40 and 2. And you would get your slope, or your rate of change would be 0.05 inches per day. Okay. So this is the outlook of what this week looks like. Today's Friday. So you're going to be doing solving systems of equation by watching this video. And then I'm not going to see you till Wednesday. So then we'll be doing solving systems by substitution that day. And then on Friday, we'll be doing solving systems by elimination. And then that Tuesday, we'll be doing systems application. And then after that, we'll be doing practicing writing activity. So this is yesterday's answer to the essential question. Make sure you pause the video and write it down if you run out of time. What is the difference between recursive sequence and explicit formula? Recursive sequence is going to be like in that circle. A recursive sequence has to give the value of the previous term in order to find the next term. The explicit formula can be used to find any term in a sequence in any order. Okay. So hopefully you guys all have your new table of contents glued in. And if you need more space, we're going to be doing 36 and 37, 11, 3, 11, 4 systems by graphing unit 5. Methods to solve systems is 3 methods. Graphing is what we're going to be doing today. Both equations must be written in y equals format. Y equals mx plus b. Graph them both. See where the lines meet and intersect, and that's how you solve systems by graphing. Substitutions is what we're going to be doing next. Single out the x and y and create a blob. And then elimination, line them up, look at the matching coefficients, add, subtract to eliminate. Okay, so there's three different ways to solve systems, and we're going to be doing graphing today. So today I will determine what is the solution for a system of equation. There's one point, that's when the lines cross each other. There's no solution, that's when the lines don't even connect with each other, that's like parallel lines. And then there's infinite solutions where the lines are going on top of each other, and there's more than one time you can have a solution. It's all a solution. Sorry about that. So here for this one, let me move this. Different slopes. The lines intersect, so there is one solution. So if you guys want to know what the missing things are, the lines intersect. So intersect would go here. So there is one solution would go here. So that's what that would look like. Okay. Today's essential question is this. Explain the process of solving a system of equations by graphing and what its solution represents. So that's what we're doing today. So key points and vocabulary. A system of equations consists of two or more linear equations in the same variables. A solution to a linear system of equations is an ordered pair. Okay, the solution must be a solution to every equation in the system. Solutions to linear systems of equations occur where the lines intersect. So, numbers of solutions of systems of linear equations. So this one, the lines intersect, so there's one solution. 1 and 2 is the solution. This one, these are parallel lines, so there's no solutions because they never intersect. In this one, this is the same slope, same y-intercept, so the lines are the same, so there's an infinite amount of solutions. So this one, to solve this, we'd have to put this in y equals. So you can do this on your TI-80 for your Desmos. For this one, I would have Desmos open because it's a lot easier. And for this one to graph it, you have to put it in y equals. And I'm going to have Desmos test mode because I want you to practice with that because that's what you're going to be given on the star. So it's going to be x plus 4y equals 16. We're going to subtract x from both sides. And this is going to be 4y equals 16 minus x. Minus x, Miss Whiting. Then we divide 4 from each term. So this would be y equals 4 minus 1/4 x. So then we graph this one. I'm going to rewrite this as well. I'm going to write this as y equals 1/4 x plus 4. Okay? And that is a little bit easier. If you're graphing by hand, it'll be a little bit easier to graph. But you can put both of these equations in Desmos and it'll work. As long as it's y equals, you can graph it. So I just did it by hand. It's a little bit clearer so you can see. Subtracted x from both sides, and we divide every term by 4. And then it's negative 1/4 x minus 4. And our solution would be here. Okay? So we'd find the solution and we'd see that it is going to be 4 and 3. That's the only place where these lines intersect, so there is one solution. So you can, how to check in your calculator, you can press y equals, you go to window, do zoom, trace, and graph. That's one way. And you type the equations in. First equation, then the second equation, and then press graph. And you can see where they cross, press second trace, and then press enter 3 times, and then it will show you. That's one way to do it. I'm really not going to press this way because it's very complicated, especially when you get to the window setting. You're going to have to adjust your window, and you would have to adjust your window to like 100, or you'd have to see if your graph can fit in the scale. And sometimes it's hard to do. Now, if you did this with Desmos, so I'm going to X out this and show you Desmos. No, I'm sliding. No, hold on. Let me go to Desmos test mode. So this is a star version, and you can only put things in y equals here. So our two equations were, that's the wrong lesson, with these two, and I'll write these to the side. Y equals x minus 1, and then y equals negative 1/4 x plus 4. I can read it. I'm going to go to Desmos, and then you can type these in. Negative 1/4 x plus 4. And then this is really easy. You could just do that and you get the point of intersection right there. You don't have to adjust the window. You don't have to do second trace. You can just type them in and then point to the dot. So like I said, you can, if you're comfortable with that TI-84 graphing part, go by all means, go for it. But me, no, I'm going to use the Desmos calculator. And you see, this is what you get on the star. The only thing is you have to put in y equals, but that shouldn't be a worry to you because we've been practicing that all the time. All right. So we're here. So it says use test mode. I'll post the link in Google Classroom. You must put these in y equals mx plus b format. And that's how it looks. And you see it gives us the point of intersection right there, 4 and 3. You cannot put this, as you see, cannot put this in x plus 4y equals 16. It will not solve it for you. It'll tell you it's an error. You have to put in a y equals. So now you're going to try these. So pause it. I want you to get the Desmos calculator and try them out. You're going to have to put these in y equals though. Okay, so once you've done that, you see that this is in y equals, and these would have infinite solutions because they're the same. So this would be infinite solutions. You put these in y equals, and then these would have one solution. And that'd be negative 5 and 4. See, not all these are in y equals, so you have to put these in y equals first. We subtract x from both sides. X minus y is 2 minus x minus x. Negative y equals 2 minus x. Then you got to divide negative 1 by each term because it's a negative. And this would be y equals negative 2 plus x. So now they're both in y equals, so you can graph them. And it would be looking like this. And these are parallel lines, so there is no solution here. So you're going to do some test practice. I do want you to stop this and test it out. You guys should be familiar with putting this in y equals. So go ahead and do that. And then we'll go over the answers. Now, hopefully you pause the video so we can go over these answers. If you see here, the point of intersection is going to be 3 and 2.5. So what's the value of x? The value of x would be 3. So your answer should be C. This one, you put both of these in y equals, and you see that the point of intersection is 1 and negative 2. These answers, same thing. You're going to put these in y equals, and you see that it'd be negative 0.2 and 2.6. So it says, what's the value of x? You're going to have to change this into a decimal. So you can put that at negative 0.2, then click math, then press enter and enter, and it will give you the answer, which would be B, negative 1/5. Then what is the solution to the system of equation? You put this in y equals, and you see where these two would cross, and you see that it would be 2 and 5. So now you're going to do graphing systems with a partner. You should have a voice level 1. If you need help, discuss with your partner. You're going to stay in your seat, work on questions, and best effort for every question. Then make sure you complete the exit ticket. And that's it. I'll be looking for those things to be done when I return. All right. Have a great day.